Welcome to Our Connected World, a podcast series from TE Connectivity featuring straight talk for engineers about today's technology trends and the technical challenges in driving innovations crucial to making the world safer, sustainable, productive, and connected. Hello, everyone, and welcome to another episode of Connected World, a podcast from TE Connectivity. I'm your host, Tyler Kern. Thanks so much for joining us here for this episode of the show today. Today, we're discussing rugged fiber optics applications for urban air mobility. And joining us here on the show is Mark Benton. He's the Senior Principal Development Engineer for Aerospace, Defense, and Marine at TE Connectivity. Mark, welcome to the show. Thanks for joining me.
Thanks for having me, Tyler. It's a pleasure.
Well, it's a pleasure having you on the show, and I'm looking forward to our conversation very much here today, Mark. So let's start off here. Throughout the traditional aerospace markets, we're seeing increased application and deployment of fiber optic solutions. So what trends are you seeing specific to the electric vertical takeoff and landing market?
Well, if you look at the traditional commercial aviation fiber optic applications, they're typically driven by weight, space, bandwidth, and EMI, electromagnetic interference considerations, given the amount of data that's required on a typical commercial aircraft. And that's driven primarily by internet access, in-flight entertainment, whether it's hardwired or whether you're using Wi-Fi access on board. But for EVTOL applications, given that the E, in quotes, kind of means electric powered, it becomes weight reduction and EMI immunity advantages that drive the use of fiber optic interconnections. And on EVTOL airframes, the volume constraint is massively important, meaning components need to be flatter, not just less volume, which optical fiber can easily meet.
So, Mark, one of the things that stood out to me, I noticed that you didn't mention bandwidth for EVTOL applications. What typical protocols and data rates are being considered, and for what functions on EVTOL platforms?
Well, most of the applications we're seeing so far are based on EMI immunity and weight reduction needs for the motor, rotor control, flight controls, where a control area network bus, or commonly known as CAN bus, and 10BASE-T Ethernet are two of the protocols of interest. These are 1 and 10 megabit per second data protocols, so as I mentioned, they're not driven by high-speed needs. But another consideration as this market evolves may well be the certification requirements to have dissimilar systems and technologies used for flight and rotor control redundancies. So one copper-based and one optical-based, for example. An optically based control system may be more immune to lightning than a copper-based solution, and therefore might give you more robust immunity and increased safety. And last but not least, applying prognostic health monitoring and health usage monitoring systems that you find on traditional rotorcraft to EVTOL platforms, that could be key for ongoing maintenance, given the increased takeoff and landing cycles for EVTOL, which is going to mean additional data logging from sensors and more cabling on the platform.
So one of the things that has been discussed quite a bit is there's this perception that optical fiber and connectors are hard to use and maintain. What are your thoughts on that, Mark?
Well, it really comes down to understanding the application and then providing for proper cleanliness and proper selection and handling of the fiber optic components. And that does not mean handling with white gloves, so to speak. Rugged fiber optic cables and connectors have been qualified and used and maintained for decades now on comm air and military ground, avionics platforms, space and subsea applications. And most fiber optic cable assemblies and harnesses today are built on production lines as opposed to field installation builds. So for the rest, just training and proper cleanliness when these production assemblies are mated in the field during installation will mitigate most of the issues. And TE Connectivity can help there with our years of experience using fiber optics in harsh environments.
So, Mark, what's the relative weight saving factor of fiber optic cable compared to some of the alternatives like twisted pair Ethernet and that sort of thing?
Fiber optic cabling has 5 components. It's got a core, a cladding, coating, strengthening fibers, and a cable jacket. And cabling considerations are often influenced by whether the cables are being routed between, say, line replaceable units, LRUs, or between LRUs and limited spaces, or if they're within an LRU. And copper to fiber comparisons depend on a specific cable configuration. So let's just consider generic baseline cables. A duplex fiber optic cable offers about 25% space savings and about 50% weight savings over a shielded PVC Cat5e Ethernet cable. And since optical fibers are inherently immune to electrical noise, because they neither receive or radiate energy, they can be applied without concern for EMI control. And that means the potential need for shielded copper cables can be eliminated, which only drives up size and weight. Another way to look at it is to say that for every rough order of magnitude, 150 kilograms, let's just say, of weight savings, one could add a passenger, or for the same passenger load, translate savings into increased flight time and range due to longer battery life between the charge cycles.
That's really interesting. The way that those two things can correlate, and you could think about them. That's really interesting. So, what are the unique fiber optic requirements for EVTOL as opposed to maybe traditional aviation?
Well, EVTOL vehicles are small, they're light, and they're oftentimes mechanically vastly different from a traditional airframe. And that translates into having products which fit into spaces that others might not. They have to be lighter than anything else and may need to be twisted into every imaginable shape to fit the airframe. There may be routing and handling challenges beyond just reducing weight from traditional products, and shrinking all the components in size all become very challenging design issues. One technology that can assist with that are optical flex circuit assemblies, which are an advance over flat flexible ribbon cables based on copper. In these assemblies, they can be comprised of hundreds, even thousands of individual fibers precisely positioned on a rugged substrate that's flexible. And so FCAs will offer multi-fiber management solutions where you have high fiber count electronic packaging. And some of those advantages include fully customizable applications for both within LRU assemblies and between LRU assemblies. They can be ruggedized with thin films encapsulating each fiber that'll help protect during the harsh environments of aerospace and commercial aircraft. And yet you have the versatility of applying crossovers and minimizing stress when you're fitting these complex routing arrangements. They can be designed to design in the minimum bend requirements of optical fiber so you can manage the radii requirements. And the material solutions to help protect the fiber also can allow you to twist and bend the fiber assemblies in any direction, which is something that can be critical for fiber routing in these non-traditional EVTOL airframe structures.
So, Mark, looking at fiber optic connector technologies used to couple fiber optic cables to LRUs, what are the considerations in applying this to an EVTOL system?
Well, if you start, fiber optic connectors are used to couple a light source, a receiver, and other components to a fiber optic cable. And there's many types of fiber optic connectors around, but regardless of which one you choose, they basically employ one of two connection technologies. There's physical contact technology, referred to as PC typically, that physically mates the two ends of the optical fibers together. The other alternative is expanded beam, or EB technology, you'll see as an acronym. And that uses lenses at the end of the fiber faces to expand and refocus the light within a small air gap in the optical pathway. So when you select between these two approaches, there's a lot of considerations to think about. They can include things like environmental variables. Are you going to be exposed to water or dust or vibration? What kind of termination finishes do you need? How much insertion loss can your system allow between your transmitter and your receiver? How much return loss or reflection? How much misalignment angularity has to be considered? And then there's maintainability. Do you have to be able to repair and clean? And will these assemblies be subject to vibration and wear? And then finally, what cable limitations do you have in terms of bend radius and wavelength ranges? And so, for example, a connection that might be mated once during an airframe build might be better suited with a PC approach. But if you have a high-speed data log download connector that's mated and unmated in the field after every flight, that'll probably perform better with an expanded beam approach.
Yeah, I'd like to follow up on that. Can you expand on the considerations between PC and EB contacts used for FO terminations?
Sure. For PC connections, there's basically two polishing approaches that are used. There's flat polishes and ultra-flat polishes for contacts that are usually used for digital optical traffic, but in sensing applications that involve optics, such as light detection or LiDAR, or RF applications where the data on the fiber optic link is analog modulated, return loss needs to be minimized. In that case, you'd go with an angle polished PC contact to minimize that return loss factor. Now, for expanded beam connectors, the lack of a physical contact reduces mating forces. Because there's lower or no spring force at all used, E-beam connectors can maintain a consistent insertion loss over many, many mating cycles. So the robustness is going to be enhanced by using that connector in harsh or dirty environments, like I mentioned previously, but there's an added expense. That's because with E-beam connectors, subcomponents and ceramics must be combined with the proper termination and polishing procedures, and these contact systems inherently involve lenses, which add a cost. However, when properly constructed, expanded beam connectors can yield consistent insertion loss values less than 1 dB. So when you look at TE's fiber optic product lines, there's a wide variety of both approaches and multiple connector form factors. They're in general use today, and they're supporting many production platforms in commercial aviation and aerospace applications.
So, you mentioned above that fiber optic cables connect a light source and detector at the most basic level. So can you expand on the type of devices fiber optic cables may connect?
In the broadest sense, fiber optic cables connect devices known as optical transceivers, which is usually a light source and a detector paired together for data protocols that are duplex, like Ethernet and CAN bus in our examples here. These transceiver devices have a specific electrical signal encoding and certain electrical levels that are required to interface that transceiver to the host circuit board system. So more times than not, they're part of a media conversion circuit, which is used typically to adjust the type and level of electrical signal used in the copper implementation and to convert that into an electrical interface that's suitable for use with a fiber optic transceiver. So media converter, by definition, involves changing the transport media of the system. And here we're talking about changing it from copper to optical fiber and back again. So you need to keep in mind, finally, that most of the systems that we deal with use digitally based protocols, but there are applications that I mentioned above, like RF and LiDAR, where analog modulation is used, but the basic idea remains the same.
Well, Mark, as we start to wrap up our conversation here today, can you explain a bit how the TE connectivity team really engages with customers in the EVTOL market?
At TE, we like to say, together, EVTOL is ours. And so basically, regardless of the technical area, be it power, cabling, fiber optics, we try to take a systems approach to understanding the requirements, some of which are often competing, and then we engage as early as we can with the customer system design teams. And from that understanding that we develop with that interaction, we can bring the TE portfolio of products together and combine that with our new product development skills so that we can innovate and create a solution that's going to best meet the overall requirements. Some options like fiber flex circuits may be bespoke to a particular airframe design, but TE in general tries to develop products and capabilities that align with the standards that are emerging so we can offer the entire market access to these solutions, which ultimately lowers costs to everyone due to the scale.
So if a customer is looking for something custom or has a system application to discuss, how can they contact your team for more information? Where should they go?
Well, I'm one of the subject matter experts on fiber optics for the Aerospace, Defense, and Marine Business Unit at TE. And those listening to the podcast can reach out to me on LinkedIn. They can reach me at email at mbenton@te.com or via the Design Faster, Smarter webpage, which is at www.te.com/design smarter faster. Alternatively, they can reach out to their local TE account representatives who can facilitate discussions between the engineering teams. And if they're not set up with a local account representative, they can reach out through the Product Information Center at TE, and they will help engage with the right engineering team. If you're not familiar with the Product Information or PIC Center at TE, just go to te.com and click Live Chat, and that will put you in touch with the PIC Center. And finally, the listeners can get more information on all the interesting innovation TE's bringing to bear on the eVTOL market at the UAM landing page, which is www.te.com/urban-air-mobility.
There you go. Lots of different ways to get in touch. If you have questions, if you want to reach out and talk to someone, an expert like Mark, you can do that via the email address he provided earlier, or like he said, go to that website, www.te.com/urban-air-mobility. Go visit that for more information today. Mark Benton, thank you so much for joining us here for this episode of Connected World, a podcast from TE Connectivity. It's been a pleasure.
Yeah, thanks, Tyler. I really enjoyed it. It's been a lot of fun.
And everyone out there, thank you for tuning into another episode of the show. Of course, stay tuned for more episodes just like this. You can subscribe on Apple Podcasts or Spotify, and make sure to go visit the TE website as well for more information and for more episodes of the podcast. And stay tuned. Those new episodes will be coming at you very shortly. But for this one, for my guest today, Mark Benton, I've been your host, Tyler Kern. Thanks for joining us. Thank you for tuning into our conversation. You can learn more about the solutions we discussed today by visiting te.com, where you can connect with our engineer support teams and sign up for Circuit, our monthly trends newsletter featuring a selection of articles on tech innovation written by engineers for engineers. To find out more, follow us on Spotify, iTunes, and Google Podcasts, as well as LinkedIn, Twitter, and Facebook. Until next time, think big, move fast, and make every connection count.